Bonjour à tous, welcome back again. My name is Jesse, and in this wonderful tutorial, we try to see how to use Spacy to do natural language processing in French. So we'll not be using Spacy to do NLP in English. Today we're trying to see how to use Spacy, the very powerful library, to work with French. So we're trying to work with the French model. So let's see how to work with it. So in English, it is natural language processing, but in French, it is TALL or TLN, right? That is le Traitement Automatique du Langue Naturel, right? My French is a little bit off. Okay, so let's start and see how to work with this particular model. So by the end of this tutorial, I'll be trying to see how to do some of the basic stuff in Spacy using the French model. So we're trying to see how to work with tokenization, right? Tokenization. Trying to see how to work with part of speech tagging. Trying to see how to extract entities from text, that is NER. To do embedding par mot, that is word embeddings, and then later in the future we try and see how to do classification de text, that is text classification, as well as analyze the opinion, which is sentiment analysis, and then further in the future we try and do some machine learning activity. So let's see how to work with this wonderful package. So to be able to work with Spacy, you just first of all have to install Spacy with pip install Spacy, and this in case you don't have it on your system. As a first step. Now, to be able to work with the model, you need a French model. So there are several options. We have the small model and we have the long model. So to install, just copy this one here. After installing Spacy, just go back to your terminal. So let's go back to my terminal, and I'm going to install Spacy, and then we're going to work on this. So it's going to be pip. So pip install Spacy. That's how to install it on your system. I've already done that, so we just move straight away to it. Then after installing Spacy, just go with this option. So Spacy, right? Download the French model. So you're going to be downloading the French model, right? For small. I've already done that, so just move on. So I can just do something like this: sudo Python 3.7. There's another alternative, and I'm going to download the large English model, right? LG, right? For the large model, to show you how it is done. Something very simple. So that is how to download the model. So that is the model we're using to do our analysis. So let's go back to our Jupyter notebook and start working with it. So these are the basic terms we'll be working on. So let's start with the first one. So let's see how to load our package. I'm going to load Spacy. So import Spacy, right? Then I'm going to import Spacy. So the normal library Spacy. Then for me to be able to work with French, right, as a language, I have to load the model, right? That is the next step. So I'm going to load my model to create an NLP object. So it's going to be, we load our model, and then we'll create an NLP object, right? So that's what we're trying to do. So it's going to be very simple. So this is not going to be NLP. This is going to be, in this case, going to be TAL, right? TAL, right? Model, right? Anyhow you call it. Very simple. So it's going to be my NLP. Then I'll just go with my Spacy dot load. Now pass in my model. So the model that you are using is a French model, so go with FR for the French model, but I prefer to always use the long format, right, so that it doesn't crash in case you are trying to make your code reproducible. So I'll copy the full code. It can be just FR. I'll put it. So in the normal way, in case you're working with English, you would have put your model here EN, right, in case you're working with the English model. But because you're working with the French model, just go with FR for the French, or use a full model, right, which is the best one. Perfect. So anytime you do this, it's going to create the same thing that we did behind the scene. The only thing it's doing at this time, it is using a different model. So this is what it does behind the scene. So behind the scene, whilst I'm loading this, it's going to create an NLP object, but it's going to be using the French model. So it's going to do the same thing we did, right, behind the scene, right, when you call Spacy.load. So this time we are using French, not English. Then it's going to do the same thing, but now it's using a different model. So all of these, any place you see English, is now going to be replaced with French. Then it's going to create an NLP object, right, or TLN object, which we'll be using to do all our activity. Very simple. So that's something very simple with it. So let's go back and see what it has to offer us. So if I go back to my terminal, now it has finished downloading, right, the French model for the long format. This is useful in case you want to work with more of word vectors. Now let's see how to work with this. So this is simple. So let's check the various methods of this. It's going to be methods, and then my attributes of this particular package I've created, of this particular object. So there are of the NLP. So this is going to tell me all the basic things I can do with this simple NLP object I've created. So this is some of the things you can do. We can add pipe. So in case I want to add my own custom French lematizer, I can also add it. We'll be learning that later. I can also check for the entities, right? Named entities. That is a normal NER. I can also check for some basic stuff. I can get pipe. I can check all the pipes within them, right? How the pipes that have been created, the pipe names, and all of these basic stuff. So let's move on to our first stacks. So this is coming from Hacker News, right? Apologies for this. So I'll just come back again, and then we start with tokenization. So tokenization is the concept of trying to break a word into 8 chunks. So the same thing in French. So tokenization, you chercher, right, to check or transform a text into individual tokens. That is the meaning of this. So you can have tokenization for word or tokenization per phrase. So let's check it out. I'm going to pick a simple word and then you try and work on it. So I'm going to be picking some words from this particular URL, from this RSS feed here, which is French. So I'm copying this one, then I'll pass it. So there's a whole video tutorial on how to pass information from an RSS feed. So you try and pass that particular information, then you use it to do our tokenization. So apologies for it being long. So it's going to be passing information. It's going to fetch info, trying to fetch some info from an RSS. It's going to be import feed parser. In case you don't have feed parser, you can just install it with this option. So to install feed parser, just go with this pip install feed parser, right? So this is not part, but this is, I'm just trying to use to fetch information from that particular place. I'm going to create a simple feed, which is going to be my feed parser dot pass. I'm going to pass in my URL to fetch some data from it, right? So this is going to fetch data. If I check it out, as we already learned previously, it's going to give us all the keys, and I want to just get an entry, one item, to use it to do analysis, right? Very simple. So I'll come back here, then I'll just create a simple entry, right? So I can give it any name, but let's call it as, let's say, example 1. Let me show you example before we move on. So f dot entries, right? And let's pick the first one. So this is going to give us the first entry, which is this. So I want to just fetch this particular information here, right? This title, and then try and see whether I can be able to analyze it, right? Or we can just pick 2 or 3. So I'm just going to call this one as this. I'll just pick the title. Then it's going to, because it's like a dictionary, it's going to pick only this particular information for us. Very nice. So let's try and see how to analyze this particular text. So I'll copy this one, and then I'll call it as my document 1, my example 1, example 2, example 3. So it's going to be example 1. Right, for example 1, to get that particular one, so example 2, the same thing, but I'm going to change this one to, let's say, 1, right? So at least we have 2 different information that we want to analyze. So if I check for the example 2, we just have some simple data we can analyze using Spacy. Very simple. This is about COVID. So let's see how to analyze the example 2, because that one looks like it's a little bit nicer, right? So this looks like there's a title, but I can also get, let's say, the summary. So let's try and see what I can be able to get the summary. So let's get the summary, sort of a title. You can also get a summary from that. So if I check it again, at least it's bigger than the previous one. Okay, this is better, right? So we're using this one to help us with our analysis. So let's change it from title to, yeah, let's use the one for title to make it simple for us. So let's see how to do tokenization using Spacy. Very simple. So I'm going to create my docs object and NLP. Now passing my example 1, right? So this is going to create an NLP object around it, going to do the same procedure that we did when we called Spacy.load, right? It's going to build a simple NLP object around the entire stuff, right? And inherit all the basic features that we have. It's going to create this particular NLP object, and on this NLP object, you can be able to do some basic stuff, right? Very simple. So let's check it out. So I've created a simple document. Then in case I want to do word tokenization, le tokenisation to mot, right, for a single word, we can just check it out by this. So this is going to be word tokenization. Let me spell it in English. Tokenization, right, which is the same thing here. I don't know whether is correct, but I hope it's correct anyway. Okay, so I'll just come back again. I don't know whether the audio is okay. Let me know if the audio is okay. Okay, so let's check it out. So it's very simple. It's going to be for token in my docs, then I just print out whatever I want to print. So I'm going to print out the token. So token.test. So this is going to give me all the word tokens within our sentence that we had, right? Very simple. So as we already know, this was our sentence. If I check this particular sentence that we had, example 1, this was our sentence, right? So this was our phrase. Say this was our phrase, and then we have tokenized them to get all the individual chunks of words there, right? Very simple, very nice. And this is very smart. So let's try another example. I'm going to try another simple example that you realize that this is smart to be able to separate them in the right respective ways because it's using a French model. So let's give another example, example 3. Then this is going to be share. Let's say, okay, let's use a word j'aime, right? So this is je suis and then aimer. So j'aime du lait, right? Du lait. I like milk, something like that. So something like this, right? In case I want to tokenize this particular one, you see that by the idea behind the model you're using, Spacy will be able to analyze it well and give us the right tokenization, right? So let's check it out. It's going to be 4. Let's create an NLP object. I'll call it as docs3. It's going to be my NLP object. I'll pass in example 3. That is j'aime du lait, right? I like milk. Then in case I want to get the tokens for this particular stuff, it's going to be something like this. So for my token in my docs3, I'll just print out my token.test. Right, if I go with this, now it's going to split them very well. Perfect. See that now J, right, is a token on its own. It means it means I. MA is also a verb perfectly, right? So that is something very simple using Spacy. Perfect. So that is not the only thing you can also do. You can also do some other stuff apart from some word analysis on this test that you have done. Before we go on to phrase tokenization, and this tokenization par phrases. So let's check it out. So this is some weird stuff you can do. So you can just go the same thing. So for we remember that we have our document like this, the one for the COVID, the long one. In case I want to get the shape of the word, whether it's a stop word or not a stop word, you can also do the same thing. So it's going to be for token in my doc, right, in that particular document that I've created. Then I can just print out the basic stuff. So I can print out the shape of the word. So token.test, that is going to be the token itself. Then I can also get the token.shape. Then you bring this underscore. So this underscore is going to give you the string representation. If I go with this, it's going to give us a number, right? So that now just give you this number. So this number is how it is being encoded behind the scene, because it was machine learning, so training the model behind the scene using only numbers. Now in case I want to get a string representation, I just go back with the underscore. It's going to give me the shape of that particular text, right? Very simple, which is very useful. And then we can also move on to the next one to check and see if the word is a stop word. So token dot is stop. So it's just the same thing that we have been doing with the English model, right? The only thing that we are using a French model. It's going to tell me whether it is a stop word. So these ones are not stop words, they are non-stop words, right? They are not functors, right? They are actual real words. But the word D can be a stop word. The word avoir, right, that is to have, is also a stop word. The word un is a stop word, and then the rest. Very cool. You can also check if the word is an alphanumeric or if the word is a punctuation. So token dot is alpha. You can also do the same thing. It's going to give us true or false. Then you can also check again if the word is, so token dot is punct. Either word is a punctuation, right? Which is very cool. So punct, you tell me whether it is a punctuation or not. Very simple. So that is some of the basic stuff you can do with Spacy. So I call it like not just word starts, but word inflections and all of these things to get more word info, right? Very simple. So that is the basic understanding behind working with Spacy for word tokenization. Now let's move on to the next step of working on phrases, right? So you can also do the same thing. Because I want to have a phrase and I want to split them into their respective aspect. I can also do the same thing. So let's check it out. So we are going to be using example 2, right? So the example 2 was a very long sentence, right? It's having some different sentences there because I want to split them. Tokenization par phrase, right? To split them into different phrases. I can also do the same thing, use the same option. So let's create my ops. So docs2, right? Then I'm going to call that my NLP object. Remember that this is using the French model. Then I'll pass in my example 2, which is a whole phrase on its own. Then I can just create my docs, right? So the reason I call this one docs is that this docs is going to create a doc span. If I check for the type of this, it's going to create a doc span. That is what Spacy works on. And this doc span contains a lot of things we can do, right? So you see that this is a doc span. That's why I mostly call it docs, right? Very simple. So this is going to be the type of it. Now I can check and see and convert them into individual sentences. So how do I do that? It's going to be sentence tokenization. So sentence tokenization, right? Or phrase tokenization. Then it's going to be for my sent, right? I can make it for my phrase in my docs 2, right? Dot sent. So that is the basic understand. So with this option, we can be able to get the sentence, right, as individual sentence. Right. So I just go back to this. Then I'll just print it out. So print. So I can print them individual sentence by sentence. So I can go with sent. Now it's going to split the entire stuff into sentence using their right punctuations. Very nice, right? You can see that I split them all. Even reportage is a sentence on its own, and this is also another sentence on its own. But I can make it better by going with this option. So let's give it a numero, and then let's split them using enumerate. And I'm going to pass in, like, I want to start from number 1 instead of 0. If I go without this, it's going to start from 0. So if I go with this option, I'm going to start from 0, and then let's create a simple object. So this, let's make it better. So I can make it like this, right? You can use string objects if you want. And then let's create another one. We are using Python 3.7, so it's still going to work. I'm becoming slow, right? Apologies for that. And then let's check it out. So this, we are using a string for that. Right, so I'm using a string, then I'm going to pass in my task. Then I'm going to loop through that and give us our result. So that's a big understanding. So it's going to enumerate them. So that's 0, 1, 2. Right, so that's given us 3 different sentences. So this is started from 0, but as you know, Python starts from 0. But in case I want to start from 1, I can just give it start is equal to 1. Then now I can start from 1. Then it's going to be 1, 2, 3. So it's able to split our phrase, right, into individual sentences. Very, very nice. To split our paragraph into individual sentence. That is something very cool, something very nice. So you can also do the same thing and get the individual tokens for all of these things. That is la tokenisation par phrase, right? Sentence tokenization. Apologies for my French. It's a long time I learned French. Okay, now let's move on to lemmatization before we move on to part of speech tagging. So lemmatization is trying to get the root word of a word, right? So lemmatization, right? Or stemming, but they are different, right? In Spacy, there's no support for stemming, but you can create your own way to get it inside. But let's move on straight away to lemmatization. So lemmatization is not the same as stemming. They are totally different. So lemmatization, you're trying to get the root word, right? The root word of that particular stuff. So let's see an example. So we're using the same example that we had here. Let's check it out. So let's use our simple example that we did, the example 3. Right, so this was example 3. I'm trying to see how to find the lemma of this particular stuff, right? So this is simple, right? We can also use the one that we had, the example 1, and then find the lemma of the individual words. So the lemma is the root word. So we want to find the lemma of this. It's going to be this option. So I created as docs, right? Okay, the simple docs, which is the same docs that we have for this test. Then I want to find the lemma, right? So you can just come back again and go with this option. So for my token, right, in my docs, and as we did above, you can also do the same thing here. So you can just print, let me print in the format of token, the format of a tuple, test, right? Then to get the lemma, just go with token dot lemma. So as we said, if you go with this without the underscore, this is going to give us the test itself and then the number, right? But we want the string representation, not the numbers. So we just bring the underscore here. This is going to give us the lemma for that particular word. Right, perfect. So Alexi is Alexi, Navarre, because they are names, but the word D is to say, right? So it's going to find the right lemma to say, dire, right? And then avoir, pager, passé, composé, then passé, the present tense, agent, agent, ruse, impliqué, right? Down, like very nice. So it's able to find the right lemma. So it's another package that you can also use called Spacy Lift, this particular package, that you can also use to do more. So maybe in the future we will try and see how to work with this particular package. So this is a package. You can also use Spacy Lift to help you do more advanced stuff with the dramatization, right? Very, very nice. It has been trained on this particular left model. Okay, or corpus. So let's move on from dramatization and then move on to part of speech tagging. So how do we do part of speech tagging? So that is very simple. It's very smart. It's able to give us something else. So let's try another example. Let's use example 3. We had, that is, I ate bread. So let's try that one out. Which was this one. Example 3 that we had, right? In case I want to try and find the lemma of this particular stuff, J, right, it's going to give us the real word, and then MA, the real word, right? So it's going to be for my token in, remember this was docs3, as you remember. I'm going to go back again, print the token, right, dot test, and then the token dot lemma underscore, right? So this is also going to split them, and you see that the J is going to be converted well, right? It's going to identify that the J is the real lemma. MA, right? Very, very nice and very cool. So do was converted to day. Very nice. So that is something very cool, something very nice with lemmatization using this French model. So let's move on to part of speech tagging. NLTK, I don't know how to pronounce it. Morphese syntactic, right? That is how to do part of speech tagging. So we're trying to find the right part of speech. So let's see an example. So we have already done that, so we don't need to be doing it again. So let's see an example. So we're trying to find all the part of speech of a particular stuff, right? So let's do the simplest first. So we have our docs, which was this one, right? If you want to find the part of speech of their entire stuff, how do I do that, right? So this is the name of a person, and he's speaking something about this, right? So in case I want to find the relation between them, how do I do that? It's going to be the same thing. So for let's for token, right, in my docs, right? Very simple, right? In case I want to find, then I just go straight away to the what I want to do. So print token dot test, going to give us the token itself, then token dot POS. So POS is going to give us the part of speech. Then you have to bring the underscore. If I go with this, it's going to give us the respective ones, but these are numbers. To get the string representation, you just bring the underscore, right? You bring the underscore here, that's going to give us the underscore. Very nice. And this is going to give us the right part of speech. There's also the tags you can also use. So one of them, this is used for in case you want to train your model, right? So token dot tag underscore, right? So either you use the POS or the tag, and the tag is more elaborative. It's going to give you a lot of information, but this is also going to give you the right tag, right? So this is a pronoun, this is a pronoun, and this is very smart in that this one gives us more information. So let me make it simple. So this is part of speech tagging. Then let's try another one. So I'll come back again to this one, right? So I want to explain these ones to make it simple for everybody. In case you have any question or contribution, you can just put it inside the comment section below, and then please don't forget to subscribe and check the links below for more. So if I go back to this one here, if I take this one out, it's going to give us a lot of information. So let's make it this way. So let's make it this way. Right. Perfect. So if I check it out, now this is how it is. And this format is very useful in case you are trying to train your model, right? Because it's going to give you more information. So Alexei, say pronoun, right? And it's the gender, right? It's masculine. French is one of the languages, French, Russian, some languages are usually based on gender, right? So we have nouns or verbs or words that are attached to a particular gender, right? Just like in French and in Russian. So this one, the word Alexei is going to give you that is the gender is masculine, right? Then the number is singular. The same thing for this one, and the same thing for these ones. I can't use this stepness. The same thing for these ones, avoir, right? So it's able to give you a lot of information about it, and then some very cool stuff, right? Very, very cool. So that is something very simple about it. Again, you can try it for the simple example, which was the docs 3. So I can do the same thing I did for the docs 3, and then it's going to give us their respective stuff. If I go back again and I check it out, so I'm changing it from docs2 to docs3, or docs to docs3, and this is going to give us the right information. So je is plural, is singular, person 1. Aimer is verb, right, and it's going to give you the person and some interesting information about it. Even le, right, which is like milk, is masculine. Very cool and very nice. So that is the basic understanding behind trying to do part of speech tagging in Spacy. Now let's see how to visualize this part of speech. So there are several ways you can do that. We're trying to see how to visualize our part of speech, and then move on to the named entity recognition. So let's see how to visualize them. Visualization to dependence. In case you want to visualize dependencies, let's put it there, right? And let's take it like that. Okay, so how do we do that? We'll be using displays to help us do that. So we're going to load our model. So from Spacy, import this Spacy. So this is going to help us to be able to visualize our dependencies and also our entities. So I'm just going to pass in with this option. So this Spacy. You can use save or you can use render. So but we are using Jupyter Notebook. Just go with render. Then I'll pass in my docs, which was, let's use the first one, docs2. Docs1, then I'll specify the style. So the style is what do I want to do? What do I want to render? What do I want to visualize? So we can have ENT, we can have DEP, right? So DEP is dependencies. So I want to visualize my dependencies. Then I'll just specify that I'm doing inside Jupyter. I'm doing inside Jupyter Notebook, so specify it as true. It's going to render it perfectly for us. Voila. And that's given us a very nice presentation of it. So Alex, pronoun, these are all referring to one another. Then this is a noun subjective, and then these are the basic ones. Avoir is a verb. D is a verb. Avoir is giving us some very nice information about these things, right? Auxiliary verb, and then the rest. So that is something very cool you can do with Spacy. Very, very cool. So let's try it with a simple example we had for this example docs3. So I get a point. So you can do the same thing we did above. So we can just go back again to displacy dot render. You can also use save in case you want. Then just go to docs3, right? And I'm going to pass in the style that I want, which is going to be my dependency. And then I can now move on to specify that I want to view it inside Jupyter, right? So it's going to render it perfectly for us. You can see that has given us a very nice dependency graph, right? So je is a pronoun and is dependent upon verb aimer. So this is referring to this, right? And then this is referring to what is eating, right? This is a person suffering. Dule. Very cool and very nice. Now let's move on to named entity recognition. So named entity recognition in French is not NER, it is totally different. Reconnaissance d'identité nommée, right? The same thing, trying to get the entities or recognize entities within a particular step. So on cherche à détecter les entités telles que des personnes, des entreprises, ou des lieux, like for places, for cities, for people inside a test, done in test. I think it's supposed to be done in test. Okay, let's move on and see how to do that in Spacy. So this one is using the pre-trained model already, so we're just going back again to the same thing. So docs3, we had our docs3, right, the one we are using. I'm trying to find all the entities within them. You can even use the docs2 or the main docs itself, right, which is the docs. Now I want to find all the entities within them. I can just go back again and do the same thing. So for entities in my docs.ents, right, that is a basic understanding. Then I can just print the token itself or the entity dot test, right? This is going to be the token. Then I can now just go with the entity dot label. If I go with dot label, as we already know, this is going to give us the entities within them, but it's going to give us the number, right? But in case I want the string representation, I just bring the underscore. So there's only one entity there, which is Alexis Navel, right? That's the only entity there because it's only just one person and it's a person, right? So in case you want to know what this one means, you can just go with in case you want to know the meaning of any stuff. So to explain something, just go with Spacy dot explain and you pass in whatever you want to explain. So pa. So it's going to tell you that this is a person, right? Very nice. So that is how to explain. So named person or a family. Very cool. You can also try the same thing that we did on the bigger stuff, because this looks very small. I'm going to try it on something very big that is having a lot of entities. So we're trying it on docs 2, which you have not created. So we're trying to create docs 2. Then going to try and see how this is a docs 2, right? So in case I want to find all the entities within this particular test, you can see that we have some places. This is an entity, and then the rest is also going to try and identify whether there are entities within them. So I'll just go back again. The same thing we did, docs 3, and this is going to give us my docs 2, rather, my entities, right? Perfect. See that it was able to identify 3 different locations for us, right? Royaume Uni, that is, and I don't know what I think is UK, Reportage, right? And then Douvre, right? So this is very, very interesting, very cool, very nice. Now let's try and see how to visualize this particular one. So you can also visualize your entities just as we did previously. So let's try and see how to visualize our entities. So using Spacy, so the same thing. So Spacy dot render as we did above. Then I'm going to, this time the style is the only thing I'm changing. So Spacy dot render, I'll pass in my docs that I want to find the entities within. Then I'll specify the style. The style is now going to be ENT, right? So this is the style I'm using. Then I want to render it inside Jupyter. So true. So this is going to render it perfectly for us and give us our result. A very nice format. Wow. So this is how to render or visualize our entities within our test. Very cool and very nice. So that is a basic understanding behind working with named entity recognition, or in French, reconnaissance d'identité nommée. Very nice. Now let's move on to the next stuff, that is trying to work with embedding par mot, that is word embeddings and then similarity. So let's see how to do that. But before we move on to similarities and word embeddings, let's do a simple noun chunks, right? So this is going to be noun chunks before. So noun chunks, I don't know how to say it in French, but we can do that in Spacy. It's going to be very simple. So I have my example here, which is example 2, which we have. In case I want to find all the noun chunks within this particular test that we had, we can also work on that same thing. So it's going to be the same thing that you have been doing. So let me make it simple, repeat it again to give you the same idea. So I can just come back again to docs 2, NLP Object, I'll pass in my example 2, right? Then in case I want to get all the noun chunks within them, I can just go with for, let's say, noun in my docs 2 dot, right? That's the basic understanding. I'll just go with noun chunks. So this is going to give me the option of using noun chunks. Then I can just look through them. So this is going to chunk the entire stuff into nouns. So a noun chunk is the word itself, and then what is describing that particular word, right? What is describing that particular noun. So I can just print out my noun. So this is useful in case you want to do keywords extraction, right? Very nice. So it's able to identify all the noun chunks within our long test. So l'arrêt brutal de liaison interdit de Royaume. This is a noun chunk on its own, and the rest. In case you also want to get the root noun itself without a description, you can also do the same thing. So let's copy this one here. This is going to be the root noun, right? Or the root test, right? So as I said, noun chunk is the noun and then the word describing that particular noun. But in case you want to get the root noun itself without the description, you can just come back again. Then the same thing we did above here. The only difference that we're just going to specify that I want to also get the noun. So I can make it like this. So noun, right? Dot root dot test, right? So this is going to give you the noun itself or the word itself without the articles, right? See that now it has split them very well, right? So that all this plenty stuff that we had here has been taken off, right? All this stuff. Very good. The day is gone, the article is gone, and then this one is even gone, right? That is gone. Only these are the true nouns there, right? As you can see from here. I don't know why lay was there, but we saw that continent is also there. That is something very simple, something very nice with this wonderful package. You have seen how to work with noun chunks. You have seen how to work with named entity recognition. You have seen how to work with part of speech tagging and dependency parsing. You have seen how to do tokenization and then dramatization. Now let's move on to the last part one on similarities. So sometimes when you're trying to work with similarities, you need a bigger and larger model to give you more word vectors. So let's try and see how to work with similarities, then you see how to work with word embeddings, right? So I'll push it up. It's the same idea. So I'm going to create a simple example. So this is going to be D1. Then I'm going to create an NLP object of a simple word. So the word I'm using is la femme, right? La femme, it is spelled E-M-M-E, but it's pronounced la femme. Then let's create another one, D2, which is going to be NLP object using the French model. Then this is going to be la fille, right? So you're trying to see how similar these words, which is a woman and a daughter and a girl, how are they similar, right? So it's going to give us numbers, and then the closer the number to 1, the more similar they are. So let's check it out. So it's going to be this. So D1, right? Dot similarity. I'm going to do similarity, and I'm passing D2. So it's going to compare them together and give us the score. And it's given us this word because we have several models. This is using a small model. That's why it's giving us this simple warning, but it's still going to work. And see that this is 0.94, right? Because they are very close. Let's try another example. Something that is totally different. So I'm adding D3, which D3 is now going to be NLP. Let's use something simple. So let's call it as something different. So la chat. Yeah, I don't know whether I just say le chat. I don't know whether that is correct, but let's pick something like that. Let's see. So I'll do the same thing. So D1, and then similarity, then D2. Right? You can use a different stuff altogether. D3, and let's see how close it is. So this has given us the same errors again, but see that this is 0.27 because they are totally different. One is a human being and one is an animal. So that's why it's totally dissimilar. The value is very low. Very, very cool and very nice. So this can be used to help us in case you're trying to build recommendation engines, right? Very nice. Now let's move on to the word embeddings. So the word embeddings is embedding per mode, which is going to be representing words in vectors of numbers. So you can do the same thing here, the simple way. So let's check it out. So for the word embeddings, the word embedding is going to be the string, the vectors, as we said. So we had our example. Let's try our main example, which was this one. In case I want to find the word embeddings for all the words within them, we can also do the same thing. So we can just come back again. And this is already an NLP object. If I check for the type of this docs, this is already an NLP object, right? Very simple, right? But this is okay. So let's check it out. It's going to be for my word in my docs. Then in case I want to get the word vector, I just go with word dot test, right? Then word dot vector. So this is how to work with it. So they're using the word dot test, using the word dot vector. Right. So this is another way of doing it. So they're going to give us every word is represented by a particular number. It's giving us an error because we spelled it as capital. It's supposed to be small letter. Right. So it's going to give us the word. So every word and then the vector, right? So these are all the vectors. So Alexi, so based on the corpus that was trained, this is the vectors, right? And then the rest, next one, Naval, and then D, right? And then the rest. So this is what's going to be used to compare in case you're trying to do word embeddings, right? Very nice and very cool. So that is something very simple with word embeddings using Spacy, right? You can make it simple. This is too broad. So let's pick a very simple sentence and try and find the word embeddings for that. So I'll try again and check something else. So let's go with D1. Let's go to the D4. Which got an NLP object for, let's say, a king, and then maybe something else, maybe queen or king or any other stuff. So that is the basic understanding, right, behind all that we have done. That is about word vector. Now let's see one last thing we can do, which is about how to remove stopways, and then I'll show you two different methods in which you can remove stopways, right? So this is going to be on removing stopways. So I'll show you the first method. So the first method will be using Spacy. You can also use NLTK, right? You can also use need test. So these are the three different methods you can use to remove stopways. There are a lot of packages can also help you to remove stopways. So Spacy, nltk, and then rest. So let's check it out. So we'll be trying to see how to use this particular one. So let's try with the first one with Spacy, using Spacy on its own. So this is going to be method 1. Using utilize Spacy, right? So you're trying to use Spacy to help us with that. So in that case, it's going to be this option. So as we learned earlier on, let's say I have my words here, docs 1, in case I want to remove all the stop words within this particular text that we had, right? So how do we remove them? So it's very simple. I can just go back to the same option. It's going to be for my token in docs. Then I'll print and say that my token dot test, right? Then this option will give us again dot stop word. We had this one, a stop, and then give us true, right? So you can use the same idea behind the concept of it being true to find which of them is a stop word or not. So any place that is a stop word is true, it's marked as true, right? As you can see from here. So I can also use the same idea and say that if the word is a stop word, then eliminate it, right? Otherwise bring it out. So it's going to be the same thing. So for token in docs, if that token is stop word, token is stop word is not equal to true, right? If it's not equal to true, then I want you to print the remaining token. So this is going to only print tokens that are the test, that are not stop words. So these are all the tokens that are not stop words, right? Very simple. So that is how to get tokenization. You can also convert this one into a list comprehension. Very nice. So that is something very nice. That is method 1 using Spacy. So I'm trying to say that if it is not a stop word, bring it out. You can also convert this one into a list comprehension. So let's try it out. It's going to be no stop words. It's going to be something like this, right? I just pass in this, starting from the back. The simplest way of creating a list comprehension. That's the first one, right? The first last. Then this is going to be the next one, right? So I'll copy this one here, right? Perfect. Then the final one is going to be the condition without the semicolon. So this is going to give us the same result that we had. So now if I check it out, it's going to give us the same thing, non-stop. Yes. So this is the first method using Spacy, right, to get stop words, to remove all the stop words from our test. Now let's see the next method. You can also use NLTK to help you with that, but let's use need test. Need test make it easy. So in case you don't have need test, you can install it with this. So pip install need test. So need test is the package that we built ourselves, right? Okay, so it can be used to do a lot of things. It can be used to make cleaning of tests very simple. I'll just go back again, and then let's see how to work with it. So in case you don't have it, you can just go with pip install need test on your system. So I'll copy this one here, go back to your terminal, then you can just install it. That's how to install need test on your system. So you can use Python 3 to install need test on the system. Very nice. So let's go back again and see how to work with need test to clean our test, to make our test more neater. So it's going to be like this. So it's going to be very simple. Just import need test and work on it. So I'll load my package. To import need test, there's two main ways you can work with need test. You can work with it in a format of object oriented, or you can also work with it in a format of maybe method oriented or functional approach. So as NT, you can also do is import need test dot functions as NFS, right? You can either use this one or the other one, and it's going to work. I have to make sure that you have it stored on the system. Let's make it NFS1X. Right, perfect. So let's see how to work with this particular package. So in case I want to clean all my tests from that, I'm going to create my docs. Let's not call it docs, let's call it just D for short. And I'm going to create my nt.testFrame. This is the object oriented approach. Then I pass in my example 1, right? same example that we have. In case I want to remove all the stopways from it, I can just go straight away with it and just remove it. So d.test, going to print out the test for us. Then in case I want to remove the stopways, I just call it as d.remove stopways. So this is the test. In case I want to remove all the stopways, just come back again, d.remove stopways. I spelled the remove wrong. I think my keyboard is faster or slower. Anyway, I'll come back again. I'll specify that I want the language that I want to remove to be French. Right, so that is the basic understanding. So I'm just changing the French. As I was saying, it looks like my keyboard is getting so lang French. So I want to specify that I want to remove all French stopways. If I run it like that, it's going to give me a test frame object. But in case I want to get the actual ways, I just go back with .test again, right? So this .test. Now it's going to remove all the stopways. So D is gone, N is gone, Da, Son is gone, just like we had above here. Right, very simple, very nice. So that is the basic understanding behind working with neatest. This is method 1 using the method OOP approach. You can also try the functional approach. This is OOP, right? And then you can also work on the next one, which is going to be MOP, right? Method oriented. So it's going to be NFS.remove. Then stopways. Now pass in the example, right, that I want to remove. Then I'll just specify the language. Right, you can either use the first method or the second method. All of them is going to give you the same result. Very nice. So that is the basic understanding behind natural language processing using the Spacy model. So to recap, you have seen how to use Spacy to do natural language processing of French in a very simple way. So that is the basic understanding behind it. So you have seen how to use Spacy. So the most important thing is that you just download the model from here using this particular command. Right, you download the specific model, then you just do the same thing, but this time you're using the Spacy model. You have seen how to work with tokenization and then sentence organization. You have seen how to fetch details from a website using feed parser. You have seen how to do tokenization, how to do part of speech tagging, how to do lemmatization, how to do name entity recognition, and then the rest. So thank you for watching this tutorial. In case you have any question or contribution, you can just put inside the comment section below, and then please don't forget to subscribe and check the links below for some interesting materials on natural language processing and then machine learning. See you another time. Stay blessed. Bye.